So, hello everyone again. My name is Julia. Glad to see you all here. And let's start. My topic today is why can developers make it secure? And before we begin, let me quickly present myself. Uh, Again, my name is Julia. This is my Twitter account. You can follow me, ask me different questions. You can tell me your thoughts about my talk later. And also I will share my slides here so you can follow me. I am a security software engineer at Kozak Labs. We are a security and data security and cryptography company. We work with different platforms, different languages. Our products are for different platforms and different languages. And my personal specialization is mobile application security because, well, yeah, I'm a former mobile application developer. Yeah, and my topic is why can developers make it secure? So I know what it feels like to be asked this question. If you ask developers what is the problem, what will they answer? Let's stop here for just a quick moment, and I'd like you to think about the answer and maybe share your thoughts in Zoom and on YouTube. I think it will be interesting for us to go through at the end and see if we are aligned on this topic. And I will share my thoughts with you as well. Okay. Um, I think that the most common answers would be that developers just have no time for security. They have very tight deadlines, and features usually have much higher priority than security controls. But you know, it's just a tip of the iceberg. This thing on the left represents an iceberg. And you know, icebergs, they are much larger than it seems from the beginning. If you give developers more time for security, if you set higher priority for security controls to be implemented, you will still have some problems because you will see that your team lacks security expertise. You will see that some security controls are in conflict with other features. And if we look a little bit closer, we'll see that the second item is usually the result of lack of secure architecture, and our iceberg is getting even bigger. I hope we are aligned on this part. If not, I will be glad to see your thoughts in chat. And for now, I want to share some interesting statistics with you. You know, some companies survey C-level executives like CTO, CISO, and others, and ask them different questions about security. Some reports may not be of the very high quality, but still they're pretty interesting to look at. Regarding tight deadlines, you see 58% say that release deadlines are often too tight to properly implement security controls. This survey is for mobile applications. And I think it's pretty realistic, right? From the same survey regarding security controls being in conflict with other features. 63% agrees that there is often a lack of alignment between departments to align user-facing features and security controls implementation. And a very sad statistics lower that only 25% of respondents are fully aware of changes made to in-house applications and APIs within their software development environment. So no one knows everything. Communication is essential here for security. A little bit more numbers about lack of security expertise and no secure coding skills. Just 32% have confidence that they could secure sensitive data. This is a little bit sad. They will probably need to hire an external security team or some other experts. 61% of applications had at least one critical and high issue not covered by OWASP top 10. So you see, very, very basic knowledge is not enough. Like OWASP, knowing OWASP top 10 and checking for OWASP top 10 vulnerabilities is not enough to build secure system, secure product. It's way too basic. And like it's just for web. 57% do not inspect data that is being transferred, returned via APIs. That is not good. It's one of the very basic secure coding things, you know, and this piece of text at the right top corner says that vulnerabilities caused by lack of secure coding are not very common in general, but they are very dense. It means that not many apps have such issues, but if they have, then they have a lot of vulnerabilities related to it. So it has very, very high density. As I've started with secure coding, I want to talk a little bit more about it. You know, secure coding is like a separate skill. Developers learn it as any other skill. It does not come by the default. There are general best practices and platform-specific recommendations to learn. And well, in a perfect world, your organization has a security training to teach these secure coding skills, not just how to detect phishing emails. But there are other options for self-education, like online materials, like for example, like OWASP materials. There are security conferences to attend, like today's one, or there are also some platform-specific conferences that may be also useful to gain secure coding skills. Here, just for the sake of example, I've listed some basic general secure coding principles. There are many, many more, but I hope that if developers are watching me right now, they know these three very well. The first one is data minimization principle, that you do not that you store only data that you really need. You know, if the API, if your backend returns you a lot of data, it doesn't mean that you need to store everything. You store just what you actually need. So this is one of the very basic principles of secure coding. The second one listed here is validate any input from external sources. Yeah, we saw sad statistics about it. You need to validate any input from the user, from network requests for any API calls, and so on, and everything you get from the database, and so on. And the third one listed here is deny access by the default. You know, like a very straightforward example is that if authorization request fails, you do not give the user the authorization rights. Like if password validation fails, you do not allow user to proceed. It's pretty straightforward example. But another example I saw in a real project is like the application was showing an image and applying watermark on it. And to get an image, it had a separate request to get an image and a separate request to get a watermark, and then it put it all together. And it was funny that if the request for watermark fails, then the application showed an image with no watermark, and that's it. It's a nice example where the developers didn't thought about the third principle. Okay, so secure coding is just a small part of what we need to build secure product. And this is a typical software development lifecycle. I hope everyone here is familiar with what it is. Yeah, we have here requirements definition, design phase, development, testing, deployment, and repeat. And if we add secure coding, it will be somewhere here during development phase. But you see, it is not enough. A lot of things are not covered. And the truth is that usually those parts may not be covered at all. Usually, well, it's pretty often case that security is postponed like a last minute feature, and such attitude is not good. We want security to be in the core of our system, not to be added as a last minute thing, like we want it like inside the core. And if security is so important, why do we postpone it? What is the problem? Because security is not visible. Usually it has no direct business value. It is not something you can sell. You can sell nice features, but not security. And basic security stuff is usually supposed to be there by the default. And you can't see if it actually working. You can only see when it fails. Monitoring is nice, but actual incidents are much, much more visible for the whole company, for your management team, for business owners. If security is not built into our core, and if security is a last minute feature, the more we delay security, the more effort it takes to be added, and the more chances it has to be ignored at all. Another interesting statistic related to it. Usually, it happens with issues and tasks that require significant changes for multiple platforms, for architecture, like big changes. The longer it takes to fix an issue, the less chances it has to be fixed. You can see here in this report that black text saying that while many flows are being addressed promptly, older flows tend to linger over time. That 1 in 4 flows remain open after a year and a half. That is very sad. And this graph also works nicely for an example with penetration testing that is done, for example, with penetration testing, because many companies do not address security during development. They just order external penetration testing when everything is ready and deployed. And they get reports with found some issues, they fix low-hanging fruits, and that's it. Everything else that requires like complex changes, big changes, is postponed for later or just ignored forever. And we don't want that to happen. We want to have security in the core of the product. And as a result, we'll have less issues found by pen testers and less problems fixing these issues. We want to address security on each step, not just during development or after the very final deployment, So here is what a secure software development lifecycle may look like. It's just one of the visions. You can find a lot of different schemes for that. It is very close to what I do as a part of external security team. So during the phase of requirements definition, we assess risks. During design, we do threat modeling and design review. During development, we watch for secure coding skills of the developers. We have some static analyzers integrated. During test phase, we do code review, security testing, and after deployment, we have, again, penetration testing, and we watch for secure configuration. Security team can assist dev team on each step. They help during every step here, like they help during risk assessment, threat modeling, design review, like on each iteration. If new feature appears, it requires like another security review. So it's not something that you've done at the very beginning and that's it. You do it on each iteration. During development phase, we may also have as I mentioned, different security trainings like secure coding trainings. During testing phase, development team together with security team can create different useful documentation, for example, security checklists, security test cases, and feature description from a security perspective. You know, not a report with found bugs, but the report that describes your feature from a security perspective, like how it works, what is important here. And then, yeah, then deployment and external, internal penetration testing. And you see, there are much more actors in this process than just developers. Actually, developers usually take care of this small part. And an important thing to understand here is that architectural decisions are usually made here, not during design and development, but during requirements definition and design. So developers do not cover everything. So I mentioned at the beginning that developers can't make it secure because of lack of secure architecture. So let's try to figure it out what the problem is and how to fix it. There is a lot of pressure in a fast-paced environment, and people make poor decisions under the pressure. And secure architecture is about decision making. People mess up processes under pressure, and secure architecture is about following the process. So, isn't it a typical responsibility for developers, like to build a secure architecture? I think it's a pretty common answer. So we'll try to answer it. And first of all, we'll give a definition to secure architecture. Secure architecture is a combination of structural security decisions. If we were talking about just architecture, general architecture, we would say that it is a combination of structural decisions. And as we are adding security here, we are saying that it is a combination of structural security decisions that efficiently addresses risks. Like our main goal here is to address risks, considering business goals. We don't need security for the sake of security. We don't want to break key features for sake of security. We want to look for trade-offs that will satisfy both business goals and address risks. Okay, you see there is a significant difference between secure architecture and secure coding. Secure architecture is an abstraction. It is about decision-making process. It is based on risks and business goals. And secure coding is platform-specific. It's about writing code. It is about following industry guidelines and best practices. Secure architecture, when you work on secure architecture, you operate risks and business goals, abstracting from the tools. And when you do secure coding, you are actually operating the tools. You do not make any business decisions. So secure architecture is about creating structure, while secure coding is about adding some details. Okay. Building secure architecture, what it looks like. First step, we define business goals. Like we were talking a lot about business goals, so here we define them. And we need business people involved for it. Like main actors for these steps are business people, like business owners or their representatives. Second step, based on business goals, so the team defines risks, measure risks, look for trade-offs. Then when risk assessment is ready, we can work on threat model, decide what security controls we need, what is the priority for each of them, how do we need to implement them, and so on. And then on the next step, we are actually implementing all of this. You see, Mm, Business owners are usually involved mainly during defining business goals and risk assessment, and a little bit on the phase of decision making and design, while dev team is more involved during decision making and building the architecture, and a little bit less involved during a risk assessment. Sometimes it works as is, but it helps to involve security team, because communication between business owners and dev team, it's really, really tough sometimes. So we are adding security experts here. And then if you still see that things are not moving properly, you probably want your security team to be involved on each step like that. And each step of building secure architecture, and of course, each step of secure software development lifecycle. It shows the importance of the team communication and shared responsibility. I would like to talk more about shared responsibility and ownership. Because no one knows everything. We always need a person to ask questions. We always need to know who is making decisions for each, let's call them domains. When you design secure architecture, you'd want to know the opinion from each domain. I mean, from business owners, project managers, software developers, UI UX designers, DevOps team, QA engineers, and so on, so on. And probably the best example here, apart from security, is QA engineers. They usually are not involved in decision-making and architecture design. However, as a result, they may not be able to automate some flows. If we add security to this example, for example, some applications have bot detection, malicious user detection, and your automated tests, like UI tests, are very, very similar to bots. And if you do not plan such case in advance, you won't be able to automate it properly. And adding a Boolean flag is prod or is test is also a bad decision. So you should think in advance how to make this feature work and how to test it. That's why even QA team should be involved in the initial architecture design. And you see, it is everything, all of this is a part of our security of our system, and each team is responsible for its own domain. So they need to raise these questions, and they need to have some expertise in these questions. And when we talk about software developers, we should understand that each platform is also different. Secure architecture requires expertise in each platform. For example, a force upgrade feature. Unlike web, you cannot control the user updates on desktop and mobile applications unless you have implemented additional feature for that. The front-end developer may be absolutely not aware that the app needs a specific feature for that. Like for web, you just update your website and it works with the new version. But it doesn't work that way for desktop and mobile applications. What is more, the feature requires backend changes, and backend developers may also be absolutely not aware that they need to do something to make your application more secure. So the application team needs to tell them, they need to communicate. Another example. Imagine a website for sharing some secret corporate images, like schemes, diagrams, and so on. And then imagine they have an Android application. And the security expert tells you that you need to have a screenshot prevention for the Android app. you ask, why would I need that? Users can easily make a screenshot like from the web on their desktop. Why do I need it for Android? Why do I need to prevent screenshots? But Android devices are different. Usually users sync their photos, including screenshots, with Google Photos or with iCloud. And sometimes they share their images with family members. Sorry. So they may accidentally share some corporate secrets with their family members, and that is not good. And you see there is huge difference between two platforms. There are very different attack vectors. That's why you need expertise in each platform you have. Next. I've already mentioned ownership, and I want to talk a little bit more. I like this phrase that if you own, you care. I like it because ownership can be like natural and assigned. Natural ownership is when you do your job and you care, you just naturally care for what you do. And assigned ownership is like you are assigned to take care of this or that part. Like it's your job, you are assigned to do that. So if you own, you care. As for me, ownership in software development process means that you understand your role, you know what you are doing and what for, and you communicate these to others. Remember, our goal here is that each member knows who to ask questions. And the person who owns some part of the system, some part of the project, uh, is a person who you can address questions to. For example, it's an example of natural ownership, like uh, like uh, let's say a personal characteristics you may look for when you hire developers. What it feels like to own a feature, like you understand the real business value of the feature you are implementing. So you just take closer look at related PRs to this feature that you've implemented. Like it's your own feature, you take care of it, you want to see how it changes. You keep an eye on updates, and you are ready to speak up if you see that some other feature may break feature you implemented. So it's natural ownership when you take care about your work. And another example of ownership, I like it a lot because it works both for natural ownership and for assigned ownership. Reading security documentation. Like, if you have implemented a security feature, you may be just you may just feel the ownership, natural ownership of it. So you are interested in reading security documentation because you just care for what you are doing. So you just go and read. From the other side, if it is an assigned ownership, if you are assigned to take care of this security feature, it's just your job to go and read the documentation. So both cases can work here. You can just assign a person to do that, or you just may be lucky and someone is already doing that. So to sum up everything that was said about secure architecture, secure architecture requires security expertise, processes, shared responsibility, and ownership. And back to the very first question. Why can developers make it secure? Like, because of this list. Because there is lack of security expertise, lack of processes, lack of shared responsibility, and lack of ownership. These things, they do not appear on their own. You need to work on them. Some teams are able to set everything up on their own, at least they will have enough security for the current moment, for their business goals. Like for the current state of what they have, they are okay. We don't know what will they need in the future. But many teams require help, and they just hire internal or external security teams. Here I've gathered some useful links. The first one is a talk from the InfoQ about secure architecture. Actually, this talk was an inspiration for my talk, so I recommend it a lot. And the second one is about secure software development lifecycle. Here is it is a video of one of this talk and a presentation. And also I mentioned two links to these interesting statistics about data security and application security. So you can take a look and see some interesting numbers. So generally, that is it from me. Again, here's my Twitter account. I will post my slides here as well. And I think we can proceed to questions and see if there were any interesting answers in the chat. Thank you.
Julia, what did I miss? There was a quiz? I could win?
No, I've asked what the audience think about about why can developers actually make it secure.
You
Maybe
mean
they
that?
have,
Okay.
yeah, maybe they
I can
have
give you
some
my
interesting
answer.
thoughts. Go
I
ahead.
can give you my answer, but you know it. It's all about, I'm Marxist by heart, so it's all about economic incentive for me. We do not pay them for security, we pay them for features. Yeah, features are visible, features are useful. Security basically is not visible, and yeah, is not useful until something bad happens. Like plumber. You never need a plumber until you really need a plumber.
Yeah, that's true. Or like extinguisher, the same example.
Yeah, the same thing. It hangs around in the corner. You never need it. It just ruins your selfies. Yeah, you have a
Yeah.
background for a really nice selfie, and there is a fire extinguisher. Why? Why on earth we need them? But when you need them, you really need them. Okay, so what do we have as answers? Yeah, I think Nastya summarizes it very much. And I agree with her. We create secure by default software. It's a good answer. Okay. Security is overvalued. Yeah, security is overrated, yeah. In this audience. Nowhere else though, but okay. We have some questions. We can jump into questions. Let me just summarize whether we have all of them here. Okay, yeah, we have. So another excuse that Anastasia has highlighted, we don't have such ticket in Jira. That's a universal answer, basically. Yeah, you wanted processes, you have them. And a question. So thanks for the great presentation. Could you please suggest some training platforms that can be used by developers to improve their secure coding skills? In parentheses, something like Pentaster Lab code review challenges, HTB Academy modules related to secure coding.
I can say that, like, as for me, when I was a developer and I tried to learn some secure coding skills, I just browsed the internet, and with no particular platform recommendations, and there were always something interesting to read. And well, it is all these articles online and courses online, they like free courses online, they are about of the same quality. And like actual trainings by security experts or actual live courses with a particular group of people is much more efficient. Like when you can ask some particular questions, when it's important to, like, if you look for a secure coding course for Java, you will not get a lot of interesting information because there are a lot of users of Java and you probably need just a small piece of that. So probably it's better like to consult some, like to look for specific courses, specific experts in this or that field who can give training to you, like a corporate training, because free courses, like they are just, or just general online courses, they're just free, like free materials online. They're not of a very high quality, from my opinion.
What do you think about Secure Flag?
I haven't. I have
haven't
no
touched it.
experience with it.
Yeah, so let me then maybe share this information. It's not free
Sure.
at all, but it's free when you are a OWASP member, which is basically virtually free, because for Ukraine it's $20 per year. So you have access to Secure Flag. That is basically, you know, like Portswigger Web Security Academy, but for source code analysis. So there are different portions of code for different development stacks and platforms and languages, and you can basically interactively find bugs, try to fix bugs, and validate whether the fixes were efficient. It looks better than anything I saw, I would say. So it's not perfect by any means, but it's really practical because it shows you the workflow, how to review the code. And I summarized it to myself as Grammarly for secure coding, you know, because as you use Grammarly, you gradually become better writer yourself. Yeah, and you use Grammarly less and less. The same way, I suppose people who develop software can use Secure Flag to like become better, more secure developers. And of course it's an OWASP project. That's why that's why I'm endorsing for it. But still, it's quite a good quality.
Yeah,
I suggest you look
interesting.
at that direction. Yeah, it's a very interesting project. Okay, other questions? We have one more question. If the developers will start to think about security, will we lose our fancy security jobs?
Oh, no, of course not.
Funny,
like,
right?
you know, just one person cannot know just everything, and security is a huge thing. You, like, a great example is one of, I had multiple projects on React Native. And you know, when you work on React Native, they have just React Native developers. But these React Native developers, they need to know like React Native, they need to know Android, they need to know iOS, and like they just have no chance to learn security on top of all of this. Like it's just way too much information for a single person. That's why security people are here, because it's just not possible to know everything. Another great example is cryptography. Like you can be a developer who knows it, but like to hire a good, let's say, C++ developer with excellent cryptography knowledge, it's just almost not possible. You are very lucky to hire one when you need one. It's much easier to hire just a good developer and a security expert separately.
Yeah, for sure. Because I know like two of them, and both of them would be really hard to hire. Okay. It's a good question, really. Thought-provoking.
Yeah, nice.
So next one is, do you think GitHub Autopilot will improve security of our software? It obviously won't if you don't use GitHub, but what chances are that if you use GitHub, Autopilot will improve the security of the software?
Like, again, I don't have experience with it. There are way too many tools in this world to know how everything works.
But the general idea of putting some security measures on a level of basically it's SaaS. Yeah, so you use a platform like GitHub or GitLab or Bitbucket, and they implement something that is available either as an option or by default, right? As they already do for what? For dependency checking, right?
Yeah.
But GitHub is now Microsoft. And just starting from there, Microsoft has like access to a lot of coders and a lot of code, so maybe there are chances.
Yeah, and again, it covers just small parts. So small parts can be improved, but main security flows, like this part is easy to automate, not just with GitHub tools, like with different tools. And yeah, you can automate some parts of the project's security check-in, but there are still a lot of parts that cannot be automated. And like these very painful flows usually happen like in error related to errors in business logic, or like some architectural decisions, not like using wrong method somewhere. Like it's something that is easy to detect, something easy to fix, and a lot of tools are already helping with it.
So maybe it will help with the technical vulnerabilities. I mean, implementation level, but not with the security flaws that are like design and architecture level, for sure.
Yeah.
Because you still will need a human for that.
Yeah.
Okay. Any more questions? If you want to grab the mic and ask questions out loud in our Zoom chat, do it now or be silent forever. No questions.
Or you can come to my next conference.
Yeah, or catch up with Julia somewhere else, because she is quite an active contributor to Ukrainian cybersecurity scene. And we are all thankful for that, as well as we are thankful for your presentation today. Thank you for being a part of NoNameCon, and good luck in your future endeavors.
Thank you for inviting me.